Sorry about that. Hello, everybody. I'm Macit. I hope all of you are having a great day so far. It's afternoon, but it looks like a night, but it's fine. We're still in the afternoon. So I'm a PhD student from University of Nottingham, and today I will be talking through my project titled Estimating the UK Truck Fleet. So I will first go through the introduction, and then I will talk you through my methodology, which is a model called FLAME, and then I will focus on the two modules from it, and then I will talk about the future work. So in the UK, there has been some regulations for decarbonizing the transportation sector. And one of them is zero emission vehicle mandate that states that all the new sales of cars and vans have to be net zero starting from 2035. And the phase out dates for non-zero emission heavy good vehicles, meaning trucks, have been defined by Department for Transport. And these policy drivers is going to affect the fuel and material demand in the future, so they're important. And there are a mix of different truck technologies and fuels available for trucks. Battery electric vehicles, fuel cells, and alternative fuels can be listed as such. And all of them brings the research question, how will the UK truck fleet dynamics will change over time? So let's take a look at the role of freight in the UK. So freight moved around the UK was 200 billion ton kilometers in 2022, and the trucks made up 80% of it. And even though trucks are less than 6% of the whole road traffic vehicles, they release nearly 1/5 of the whole UK road transport emissions. So the methodology used life cycle assessment as part of it. So what is life cycle assessment? As we know, there are like material and energy flows to any product or service. And life cycle analysis addresses the environmental consequences related with these flows. So this visual is like an example that's showing fuel cycle and a vehicle cycle for a vehicle. We can see the fuel cycle is from valve to wheels, and vehicle cycle includes from the manufacturing until the end of the life of the vehicle. So most studies take a look into one of these cycles. In contrast to FLAME model, which is the short for Fleet Life Cycle Assessment and Material Flow Estimation, looks into the whole LCA of the fleet. And it consists of different modules inside of it that are like fleet module, which deals with the size of the fleet, population change, and average haul length. Vehicle module deals with the vehicle itself, weight of it, materials of it, and the energy consumption while creating it. And then there's this manufacturing model, materials module, energy module, and all those modules feed into the life cycle assessment of different technology scenarios with this fleet. So today I will be focusing on fleet module and vehicle module. So fleet module, with the name comes, it deals with the dynamics of the fleet, and the demand for freight transportation defines the size and the new sales of the fleet. And the population of the fleet is affected by, of course, new coming sales of the trucks and the trucks that are coming end of their lives. And this module also deals with how this fleet is utilized in the operations. So let's take a look at the current heavy goods vehicles characteristic of the UK. As of 2021, there are like total 530,000 licensed heavy goods vehicles in the UK. And we can see them in the different weight categories. There's like up to 7 to 8 tons, and it goes over until over 41 tons. And we can see that nearly 1/4 of the whole fleet is over 40 tons. Average haul length for each journey for all of the vehicles is 108 kilometers, and around 30% of all vehicles are running empty. And here is the same number of heavy goods vehicles in 2021, but this time divided by number of years since their first use, meaning their age. And why is this age important? Because with the historical data that we know, the first registration date of the vehicles, we can calculate the survival rate of the truck fleet. What is survival rate? Survival rate is a rate of which an HGV of age A survives to become of age A plus 1. So meaning like surviving till next year, growing up 1 year. And annual and cumulative survival rate is calculated. And when we check the cumulative survival rate line, the halving rate, 0.5, comes down to the year 8. So means the average lifetime of a truck of the UK, in the UK, is 15 years. So we talked about the phase out dates defined by the DFT. This is as such. So it says that after 2035, all the trucks that are under 26 tons, new trucks, has to be net zero technology. And after 2040, it will include all the trucks, the ones over 26 tons as well. And then when we think of like how much of the trucks today are net zero, the number of battery electric heavy good vehicles in the UK at the end of 2021 was 520, which is like 0.1% of the whole fleet. And at the end of the September 2020, this number was around 1,000. So it doubled up in a year, which is good. And so since this phase out dates for 26 tons up and down, when we divided the number of HGVs in this category, we can see that the over 26 tons, like the larger trucks, are increasing in size in the recent years, increasing in number in the recent years. So given all those characteristics and the demand for the future of freight, defined in different reports such as UKR and National Grid, the HGV sales and the fleet size is calculated. And they are divided in two classes, meaning zero emission vehicles represented by green in this graph, and the rest of them are labeled as conventional vehicles, meaning they're using conventional technology. And we can see that the sales graph was made to include the minimum number of trucks that will be included according to these regulations. So this is the minimum thing that can be done, but obviously more can be done. And we can see that after 2040, all of them becomes green, and exponentially it goes to up to 25,000 trucks in 2035, meaning nearly all ones less than 26 tons are green. And this is the whole fleet size, the graph on the right-hand side shows. And if it goes like this to the plan, we can see that in 2031, half of the fleet becomes net zero emission vehicles. And in 2050, this rate is around 80%, meaning there will still be conventional vehicles in the fleet. So in the vehicle module, the different available technology and the fuels are to be considered. And again, the same reports by National Grid and UKR's research, 5% of the UK heavy good vehicles fleet are to use hydrogen as a fuel, is defined as like 5% for 2050. And hydrogen IC trucks and infrastructure policies are seeming to be promising. And there are also available e-fuels and biofuels, especially renewable diesel, which can easily be used as a drop-in fuel in the existing HGVs, which is great in terms of like immediate solution for decarbonization. And also market share studies are being looked into to define the trucks that are mostly used. And it can be seen that rigid trucks that are small and medium and articulated trucks over 40 tons are the trucks that are mostly in use. So what will be done in the future in light of this research? Estimating fuel use of the fleet and the fuel prioritization between modes will be looked into, because as the lightweight vehicles are being electrified rapidly, biofuels and other renewable fuels are being freed up, and this can be used in different modes of transportation, like for trucks and rail. And developing of feasible scenarios, including different technology mix for trucks, will be developed so that the different scenarios have greenhouse gas life cycle emissions can be calculated as a result. And this could be so that it could provide different options for the future and compare different development scenarios. Thank you for listening. You can take questions now.
Yeah. Yep.
You mentioned the 26-ton cutoff, but
You mentioned 26-ton cutoff, but in your slides, you quantify the market or size the market completely different to a vehicle manufacturer. So earlier on in your slide, you talk about 18 to 31-ton trucks.
Yeah.
So where do we get the data for the number of 26 tons? Because that's quite significant.
Yeah, there are different documents available on the DFT website. In one document, it divides the weight categories as in the graph, and in the other one, we can see them up to 26. And yeah, so one of them allows us to actually see them by 26 tons, and the other one, categorization is different. It's actually an important point that you mentioned, because this will like getting the right data is important, because if the documents state different weight categories, it's hard to define which one to use.
Have you finished this report now, or is this still work in progress? Or
it's a work in progress, but the report is consistent on the recent numbers, DFT, like updating it. So I'm also updating myself according to
as a vehicle manufacturer, we're quite happy to come and sit down with you if you'd like that.
I would like to. Thank you.
Yeah, that's Volvo, if you didn't know. So sorry, Adam was firstly.
Sure it was, but okay. Just very quickly, the although it's obviously still a very small number, you mentioned that the number of battery electric vehicles on the roads has doubled in the last year, right? What sort of use cases? Do you any idea what sort of use cases that would be? Sort of is it sort of companies sort of doing trials of things, or just sort of very short haul?
The last one that I know, the most recent trial that I know that was finished was BET's electric trial, battery electric truck trial, that was made on like medium-sized rigid trucks. There was like 20 trucks, and they looked into it for a year about their operations and how much they are used and how they're used, basically. This is the most recent one that I know, but I don't know about the rest of the 500 of them.
Okay, we're going to take one question here, and I understand there's some online questions, so I'll quickly jump to that.
Right. Thanks. Very briefly, where did you get your assumptions for the fleet size growth out to 2050 from? Because you hear that the demand is probably going to grow by rather more than that by then.
Yeah, so the reports that I looked into was UKRI's Future of Transport estimations, and also National Road Traffic reports. They both suggested, like, they both said they're like estimating a 12% increase from 2018. So I adjusted the numbers from 2018 to 2050.
Two questions from online. First one, does your projection consider payload and travel distance?
By what?
Does your projection consider payload and travel distance?
No, it hasn't yet. But as the vehicle fleet will develop during the study, I will be able to include those, and so that I can calculate the emissions from them.
Okay, and then the second question, which dynamics did you consider in your model?
In terms of which dynamics, I mean, I don't know how to answer that. I just like develop the model so that I can see how the survival rate of the fleet will change according to the types of the trucks.
Okay.
So it's a stock flow model.
Mhm, mhm.
Okay. Any other questions? I think we've got, she did a very quick presentation, so that's you get more questions if you have a short presentation.
Hi, I'm Brian Robinson, Zemo Partnership. Are you around for the next couple of days, to tomorrow as well?
Mhm.
Because I'll get your contact details. Zemo published a report a couple of years ago that did most of this stuff on actually I did it on an Excel spreadsheet, looking at how fuel consumption, diesel demand would change based on various projections about the uptake of battery electric vehicles. So it'd be very interesting to see if you come to the same answers that I did 2 years ago. But my question was actually around, are you going to model, because the slide you showed with the percentage of combustion engine vehicles still around in 2050, on the basis of our modelling is quite misleading, because the older trucks do less miles, which means the very old trucks, they're irrelevant because they're doing so few miles, they're not burning any fuel, they're not producing any emissions compared to the newer ones, which are doing much higher mileages. So you really need a kind of an energy model rather than just a fleet size model.
Yeah,
Is
you're
that
right.
part of
This
your
is
thinking?
Yeah, exactly. At the end of it, I will be able to calculate the energy use and the emissions used from the operations of the fleet. Right now, it's just the numbers of the zero emissions and that, and this will even verify, like, because I just classified them like simply as zero emission and conventional, but this zero emission will also go into details of what kind of zero emission.
Okay, and I think that question ties in with the online question about payload and travel distance, because I think that's in terms of which vehicle does what, which complicates the model very much more, but we leave that up to you to solve. Okay. Thank you. Another applause, I think, is